66 million years ago, something fell from the sky. It was traveling at around 20 kilometers per second. It hit what is now the Yucatan Peninsula in Mexico. The explosion released energy equivalent to 1 billion atomic bombs. 3/4 of all life on Earth died. The thing that did it was not a comet. It was not a missile. It was a rock from space. And there are millions more of them out there right now. Welcome to Beyond the Cosmos. I am glad you are here. If you are new to the channel, hit subscribe now. We put out a new episode every week covering the science, the mysteries, and the raw scale of the universe. Turn on notifications so you do not miss what is coming. Today we are talking about asteroids, what they are, where they come from, what they have done to this planet, and what humanity is doing about the ones that might be heading our way. Let us start at the beginning. What exactly is an asteroid? An asteroid is a rocky body left over from the formation of the solar system about 4.6 billion years ago. When the planets were forming, not everything clumped together. Some material was scattered or left behind. That is what an asteroid is, a leftover. They vary enormously in size. Some are a few meters across, some are hundreds of kilometers wide. The largest asteroid we know of, Ceres, is about 940 kilometers in diameter. It is so large it is now classified as a dwarf planet. Asteroids are not the same as comets. Comets are mostly ice and dust. When a comet gets close to the sun, the heat causes it to release gas and form that iconic bright tail. Asteroids are solid rock and metal. No tail, no ice, just rock, hurtling through the void. They also look different from meteors. A meteor is what you see when a space rock enters Earth's atmosphere and burns up, the streak of light in the night sky. If a piece survives and hits the ground, it becomes a meteorite. An asteroid is what that rock is called while it is still out in space. Most asteroids in our solar system live in a region called the asteroid belt. If you picture the solar system as a set of rings, the asteroid belt occupies the fourth ring out from the sun. There are millions of asteroids in the belt. Some estimates put the number at over 1 million that are larger than a kilometer across. Smaller ones, there could be billions. But here is something that surprises most people. If you gathered every asteroid in the belt and combined them into one object, it would still be smaller than our moon. The belt is not a dense field of chaos the way science fiction movies portray it. Most of the space between asteroids is enormous. Jupiter plays a big role in keeping the belt in order. Its gravity acts like a shepherd, pulling on asteroids and preventing them from ever coming together to form a proper planet. But Jupiter's gravity also occasionally nudges asteroids out of the belt and onto new paths. Some of those paths lead closer to Earth. Near-Earth asteroids are exactly what they sound like. Asteroids whose orbits bring them close to Earth. As of today, scientists have cataloged over 33,000 near-Earth asteroids. Of those, roughly 2,300 are classified as potentially hazardous. That classification does not mean they are going to hit us. It means their orbits come within a certain distance of Earth's orbit, and they are large enough that if they did hit, they would cause serious regional or global damage. NASA and other space agencies track these objects constantly. The Center for Near-Earth Object Studies, based at JPL in California, monitors the sky and updates impact probabilities as new data comes in. Most of these objects have near zero probability of impact in the next century. But the key word is most. The one that gets discussed most often is Apophis, an asteroid about 370 meters wide. When it was first discovered in 2004, early calculations suggested a small but real chance it could hit Earth in 2029. More detailed tracking ruled that out. But Apophis will pass closer to Earth than many satellites. We will be able to see it with the naked eye. We know what a large asteroid impact looks like, not because anyone filmed it, because it happened, and the evidence is still in the ground. 66 million years ago, an asteroid estimated at around 10 to 15 kilometers wide struck the Earth at the site of what is now the Gulf of Mexico near the Yucatan Peninsula. Scientists call the impact site the Chicxulub crater. It is 180 kilometers wide and buried mostly under the sea. The impact itself was catastrophic, but the aftermath was worse. The collision threw billions of tons of debris into the atmosphere. Dust and ash blocked sunlight for years. Plants died. Then the animals that ate plants died. Then the animals that ate those animals died. About 75% of all species on Earth went extinct. including the non-avian dinosaurs, which had dominated the planet for over 160 million years. We are here today partly because of that impact. The mammals that survived were small. They lived underground. After the dust settled, they had a world mostly emptied of competition. They spread, evolved, and eventually, one branch of them stood up, made tools, and started looking at the sky. Small asteroids can cause enormous damage, and we often do not see them coming. The good news is that humanity is not sitting still on this. Planetary defense is a real field of science. The goal is simple: find every large near-Earth asteroid before it finds us, characterize its orbit, and if one is heading our way, figure out what to do about it. Telescope programs like Catalina Sky Survey, Pan-STARRS, and Atlas scan the sky continuously looking for moving objects. When a new object is spotted, its position is tracked over days and weeks. From those observations, scientists can calculate its orbit with high precision and project where it will be decades into the future. The European Space Agency and NASA share data through the International Asteroid Warning Network. Could an asteroid hit Earth again? Yes. The question is when and how large. Small impacts happen all the time. Every day, around 100 tons of space material enters Earth's atmosphere. Almost all of it burns up. We call it shooting stars. A 50 to 80 meter object is estimated to happen roughly once every few hundred years. A Chicxulub scale event, 10 kilometers or more, is estimated at once every 100 million years or so. The honest answer is that we are not going to see a civilization-ending asteroid hit in our lifetime. The risk in any given year is extremely small, but it is not zero. And unlike most catastrophic risks, this one is actually preventable. We have the technology. We need the funding, the international cooperation, and the will to use it. We are the only species that has ever looked up at the sky, identified a threat, and had a plan to stop it. That is something worth taking seriously. The universe is not designed around our comfort. Rocks fall, stars explode, galaxies collide. But for the first time in the history of life on this planet, one species has the awareness to see what is coming and the capability to do something about it. If you found this video useful, hit the like button. It helps more people find the channel. Subscribe to Beyond the Cosmos and turn on notifications. We explore the universe every week, and there is a lot more to cover. We will see you in the next one.